All right, hello class. In this video, we are going to go through the wastewater management class survey example. You should have the packet in front of you now. And I'm going to, kind of like you're on a learning how to ride a bike, right? I'll be behind you for the beginning of it, and then at a certain point, I will release you and then see if you can take on the wheel yourself. So let's start by going over to the back page or wherever your survey is. And let's talk a little bit about what a survey is, because this looks kind of intimidating, I'm sure. So this is a survey. It is actually a survey that I got from the previous company that I worked at. My goal here is to try and give you a real-world example of what a civil engineer would do related to stormwater management. So hear me out. I'm going to explain it as if this was a lecture. Okay, so let's look at the survey and let's try and make heads or tails out of it. Okay, let's zoom in a little bit and then we'll move over. Okay, so a survey is mapping out what's already existing on a property or an area. So they've mapped out several houses and everything. I'm not sure what they were working on. Normally, wouldn't it be more properties than what you need? That would be expensive, but let's look at what we have here. We have a 1.5 story, building, so kind of like a split level. You have a concrete porch right here, a walkway. You have a patio. You have outdoor pool out here. You have trees over here, and you have your roadway in the middle of the street with the concrete walkway leading up to the house. Then this house right here, their next door neighbor, has similar types of buildings. You have an AC unit, wood steps. OH would stand for overhead electric. So there's going to be an electrical utility pole right here. That's what UP stands for. There's an attached garage, or they call it a cottage. I guess it's finished, and so on and so forth. Come over to the other street. Oh, let's look at the street, I suppose, too. Here's going to be the street as well. It says edge of pavement, curb, and you just kind of have to look. Everything is labeled. You have another building over here, overhead light. G is where the gas line is. This street has 2 gas lines for some reason. Now, they don't actually see the gas lines. They kind of see like gas manholes or gas caps, or if they spray paint sometimes. S would be for, could be storm, could be sanitary. We have to see a little bit further where it's labeled. You have where you have your inlets for your stormwater management, so on and so forth. Here's your storm manhole, and then all the information that you see when I give you class. And that's the general gist of it. It has a legend up here to explain everything that you might not know intuitively what it is. And that's kind of it. So every project as an engineer, you start with this survey. You will be handed this survey by your surveying crew. And then say, for example, I'm going to demo this building. I would want to know what's fully here before, and then I'm going to propose what I want to build on top of this property. So I would gray out all of the existing, and then I would make my proposed dark black so I can really see what I'm trying to show after I propose what I want to build. And you want to avoid things like utility poles. You want to minimize how many trees you disturb because those are expensive. You want to know where your gas and your water and your electric and all that good stuff are because you're going to try and tap into them. All right, let's go back to the example. In this project, we are going to design the suppose we have to redesign the wastewater of this house and this house right here. And our design must be sloped downward. You should know that. The top of the sanitary sewer line must be 3 feet below grade. So what that means is if that's like the top of your surface, a wastewater pipe has to be at least 3 feet from so that looks like the smallest point. At all points, it has to be a minimum of 3 feet at all points. If anything above that, it could always freeze. So that's 3 feet from the top too. So from the bottom, we usually do about 4 feet to the bottom of the pipe, because these pipes are not going to be any more than like 6 inches usually. And then they have some thickness. So we usually say it's like 4 feet to the bottom, to the invert, I should say, roughly. Other things to note is if it's a relatively steep slope, let's do something like that, and you have your house right here, and you are going, you have to make sure that you maintain the slope of the natural land. If you have your slope be like 1%, look what's going to happen when you go downstream. Again, this is the house right here. Boom. You can never have a daylight like that. So if the natural slope of the land is, say, 4%, you're going to have to maintain at least that to be able to maintain that 3 feet of clearance. Okay? Other general things to note, you should avoid disturbing as much as possible. But of course, a lot of times that's inevitable. Sanitary sewers should be avoided from getting too close to a water line. But if that's unavoidable, sometimes it is, you have to just add some coverage. If there is a confliction, remember you can reroute pressurized pipes, but this should be avoided. And by no means can you conflict with a stormwater pipe, because they're both gravity, and any rerouting will result in upward slope. Remember, this is a real world example. This is like as real as I could possibly make it. This is very similar to what an engineer would have to do when they're working on the stormwater or a wastewater portion of a building. All right, now let's go through some of these questions. We need to estimate the elevation of the house where the sanitary sewer line is leaving. We're going to focus on these two buildings right here. So to estimate the elevation, we have to look at the contour map. This also has a contour map built into it. So you might remember contour maps from like, history class or whatever. So like right here, this 17, that's showing where it's 17 feet of elevation. These little spot shots here are just showing you individual elevations at that exact location. We have another contour right here, 18, then 16. So generally, we can see that the slope is moving in this direction. 18, 17, 16, here's 15 over here. It's the whole property's drainage is moving in that direction. So that matters because when we're going in this direction, we're going to have our sanitary line tap into here, and then coverage shouldn't be a problem, because if we're good with coverage right here, meaning we have 3 feet above our pipe here, and they're moving away from the gradient, we're always going to have enough coverage. Let me quickly draw that example. So if this is our house right here, oh, I did it backwards. If this is our house right here, and the sanitary sewer line is in the street over here, if you have 3 feet of coverage here, you're going to have way more coverage over here. So that's good. If it was the other way, if it was something like that, then you would have to make sure that you had 3 feet of coverage maintained throughout the entire time of the project. So that's good. Okay, so question 1 is asking, what's the elevation of the northern house? So let's go with right here. The first floor is 19.4, but that's not really, I see an 18 right here. Yeah, around 18. I think that's fair. Roughly 18. It doesn't have to be an exact. Then you go down to over here, the southern one, and I see 18.4, 18 right here. It's moving downward. 18.23, 18.14. Yeah, I would say it's also around 18. You can even do like the around if you want. It doesn't really matter that much. And if anything, you can be a little conservative in your estimate. So let's estimate the starting invert of the northern house. Okay, so this is our house right here. If we're estimating that right here is elevation 18, we want to know the starting invert right here. So we know that we're going to need 3 feet minimum. And then we're going to know we're going to have to go down the pipe thick diameter, which is probably going to be 4 inches, maybe 6 inches, maybe 3 inches. So you could do any value at least 3.5 feet lower than the starting elevation right here, or the ground elevation, I should say. That's the point right here. Meaning that this starting invert needs to be at least 3.5 feet lower than that point right there. Let's round up to say 4. Sometimes you have to reiterate, like you'll start with easier numbers, and then if you can maximize it, you'll go back a second time and fine tune the numbers to make them a little bit more precise, a little bit more inexpensive design. Let's say 14. That'd be 4 feet lower than what's right above it. Plenty of clearance. Okay, cool. Now we will look at the sewer main in the street. Okay, so now where are we tying into? So say this is going to be right here, right there or whatever, and we're going to tie into this sanitary manhole in the street. Now you should recognize some of these information that's given. So we have a sanitary manhole. The rim is 17.66. That's like where the manhole is at ground level. And then if you pop open the manhole, you have a rim elevation of 11.21 for A, and then 11.06, which is B. So B is lower than A, so it's moving in this direction. This is the downstream one. And now let's go down this pipe. And here's your upstream manhole. You have the rim at 17.09 and the invert at 12.86, meaning this is the starting elevation is 12.86 and the ending elevation is 11.21. So starting elevation was 12.86. And the ending elevation was 11.06. The linear length of the pipe, what is that length right here? All right, we'll have to go to the bottom right, or it doesn't always have to be there, and estimate based on this scale right here. So 1 inch equals 20 feet. So that is your unit for what is 20 feet. So I'm just estimating right now. Obviously, if you had real technology in front of you, you can do a little bit more. All right, it looks like it's probably around, let's just say 280. That could be way off. It doesn't really matter for the sake of this project. 280 linear feet. So you guys can then figure out the slope right there. Let's get the distance to distance from northern house to northern manhole. Okay. Actually, I'm going to run out of time. I'm limited to 15 minutes per video. So I'm going to end this video now. In the second video, we're going to get the rest of this top information and then explain this a little bit, and then you'll be on your way to finish off this project.